In this video, I am going to try to explain how we can solve problem of elastic potential energy. We finished the kinetic energy and gravitational energy. Now this one is about elastic potential energy. Now, something that you need to remember is the equation of elastic potential energy. If we remember, we have the elastic potential energy is going to be US is going to be equal to half K, and this K is the constant on the spring. That means what is the strength of the spring? If the spring is strong or is more weak. And this K is going to tell you how strong or how weak is the spring. The X is going to tell you how far you compress or you stretch the spring. Now, talking about the units, in this one we have the US, that is the elastic energy. The unit is J. For K, that is the constant of the spring. The unit is Newton meters. And for X, that is we can say right here, the length, the distance is going to be meters. And then right here we have elastic potential energy, the constant of the spring, and the distance that the spring is being compressed or stretched. And the unit is joules, Newton meters, and meters. Now, let's go right here. We're going to do 3 problems to explain how we can solve an equation using the topic or the equation of elastic potential energy. First problem, say right here, determining the elastic potential energy that is stored in a spring with a spring constant of 250 Newton meters that is being compressed 0.8 meters. If you remember, it doesn't matter with what equation or what are we doing in physics, always the first step is going to be data. Now, let's go right here. First data in this problem is going to be that we want the elastic potential energy. That means we want US. We have the spring constant that is equal to 250 Newton meters. That means that lower K, I don't even know how to do a lower K, whatever, is 250 Newton meters. And we also have the distance that is being compressed, that is 0.8 meters. I mean, X is going to be 0.8 meters. Second step, we need to write the equation. The equation for this one is US is equal to half KX squared. Now, using this equation, we have the first step, data. Second step, write the equation. Third step is we need to ask a question. The letter that we want is a number or is not. And we see right here, US is a number. The elastic potential energy is a number. That means we don't need to cancel the equation. We only need to change it by numbers. Now, the elastic potential energy is going to be equal to half multiplied by the constant of the spring, that is equal to 250, and multiplied by X, that is equal to 0.8. And something that you need to be careful is that this X have the square up there. Right now we have everything. We need to calculate in the calculator, and we have right here half 250 and 0.8 to the square, and the answer is going to be equal to 8. And remember, the unit is going to be joules. Now, let's go to the next problem. In the second problem, we have what is the spring constant of a spring that is compressed 0.5 meters and have 0.65 joules of elastic potential energy. I always, first step is going to be data. We want the spring constant, that means we want K. Then, what we have is the X, what is the length that is being compressed? Like 0.5 meters. And we have the elastic potential energy, US, that is 0.65. Now, we're going to write the equation. Let's say US is equal to half K X squared. Now, we're going to the step. We have data, we have the equation, we need to ask the question. The letter that we want is along or is not. If you see right here, it's not along. What we need to do, we need to cancel the equation. And we need to do the step that I've been teaching for the whole year. How we cancel the equation? We need to do the opposite that we see. If we want K, K is being divided by 2 or is being multiplied by half. How we cancel? If this is being divided by 2, the opposite will be multiplied by 2. We're going to be multiplied by 2, but remember, whatever you do in one side, you need to do it in the other side. Multiply here by 2, we cancel, and then we write below what is left. 2 elastic potential energy equal to half X squared. And we do the same question again. This letter is along, yes or no? It's not. These two letters, they are being multiplied one by the other one. That means we need to do the opposite. The opposite of multiplication is what? Division. That's why we're going to divide by X squared, and we're going to do it in both sides. We cancel, and now finally we're going to have K is equal to 2 US divided by X squared. And if you see, I flip the equation also to try to have the letter that I want on the left. It looks better. It's the same way, it looks better. Now that finally the letter is along, we need to change letter by numbers. And we have over here 2 multiplied by 0.65 and divide by 0.5, and remember that these have a what? A squared. And we can do it now in the calculator. And we have 0.4 fraction. We have 2 that is being multiplied by 0.65 and divided by 0.5 to the square, and the answer that I have is 5.2. For this one, we have that K is going to be 5.2, and the unit that is newtons meters. Good. That's problem. So, how much does the spring constant of 500 Newton meters need to be compressed in order to store 1.75 joules of potential energy, of elastic potential energy? And this is what we're going to do right here. First, data values. We want to know what is X. Second, we have that the spring constant K is equal to 1.75 joules. And we have that the elastic potential energy is equal data. First, we want have not the spring is being compressed, we want X. Second, we have the spring constant that is equal to 500, that means K is going to be equal to 500 Newton meters. And the elastic potential energy is 1.75. Now, that's the first step. Second step, we need to write the equation. US is equal to half K X squared. Now, If we're looking for x, like the last problem is not alone, we need to cancel this equation in order to be x alone. Now, this x is being divided by 2. The opposite, like you know, is going to be multiplied by 2. And whatever we do in one side, we need to do on the other side. Now, we can cancel the half with the 2. And we are going to write below what is left, yeah? 2 elastic potential energy equal to k x squared. Now, if you see x is not alone again, we need to cancel now. X and k are being multiplied, and the opposite of multiplication is division. That means we're going to divide by k on both sides. Cancel. We switch the equation. And now we have this part right here, but x is not allowed, we need the square. The only way to cancel the square is going to be using the square root. But like always, whatever you do in one side, you need to do on the other side. Now, this square root and the square cancel each other. And finally, we have x alone. And now we can change it by numbers using that. The square root of 2 multiplied by 1.75 and divide by 500. And now we can use the calculator. And be careful here. Always we need to start with the square root, fraction, and now we can type all the numbers. And we have that the answer is going to be equal to 0.08 meters. And we are done with the problem for elastic potential energy.